Training SageMaker locally is something I have found to be very useful because of two main reasons. Number one, it allows me to debug or test training and inference scripts before provisioning any SageMaker resources. Number two, it helps reduce development costs, as most of the testing, which typically drives up development expenses, is done locally. If learning how to train SageMaker models in your local machine sounds like something you are interested in, let's dive in and get started. To train your SageMaker model on your local machine, there are two key prerequisites you need to meet. First, set up the SageMaker development environment. This includes installing Anaconda, creating a SageMaker development environment using Conda, and finally installing required packages such as AWS CLI, Boto 3, SageMaker SDK, and Jupyter Lab. If you need guidance on how to set this up, check out my previous video where I walk through the process of creating a SageMaker development environment. Secondly, install Docker and Docker Compose. When running jobs in local mode, the SageMaker SDK automatically generates a Docker Compose YAML file with your job parameters and starts the relevant container locally. So, once you have these prerequisites in place, you are all set to begin local development. Now, I will navigate to my local Jupyter Lab to demonstrate how SageMaker training works in a local environment. Here is the notebook I will be using for this demo. So we'll go ahead and import the necessary libraries. After importing the necessary libraries as shown here, the next step is to specify the SageMaker session and role, which is what we have here. Now there are two key points to note. First, the local session. We are using local session instead of the typical session because we want SageMaker to track the training activities happening on our local machine and not on AWS resources. The second key point we need to note is that we are manually specifying the IAM role. This is because we are doing the training on our local environment and not on AWS SageMaker Studio or SageMaker Notebook instance, where the role can be automatically retrieved using SageMaker.getExecution role command. Now let's go ahead and run this code. Now that we've set up this session and role, let's move on to training the model. There is quite a bit of code here, but I'll focus on the key parts you need to understand. First, since we are training an sklearn model, we will be using the SageMaker sklearn framework as indicated here. What differentiates the parameters for training locally versus on AWS resources are two things. The local SageMaker session, which we have specified here, and the instance type, which we set to local. You can also set it to local GPU if your machine has a GPU. All other parameters are typical, like specifying the entry point for the training script, the Python version, the framework version, and the hyperparameters. Another important thing to note here is the local output path, which specifies where the trained model will be saved. In this demo, I have set it to a local folder called trained model, which is located here. So upon completing the model training, we expect the model to be stored in this folder. The skEstimator.feed method initiates the training process, and here is the S3 bucket path that I have specified. If you are following along, make sure your data is also stored in an S3 bucket, as the train.py file which I have here assumes this. Let's go ahead and run this training. So the training is ongoing and we'll just hang in there for it to complete. Notice that it is starting to pull this image, which is the base scaling image I just mentioned earlier. So it's starting to pull it from the registry. So our training is now complete. As you can see here, you can see reporting training success. If I check the local output path, which is this folder, we see that our module, which is indicated by model.tar.gs, has been saved there. If I also check the Docker images now, you notice that there is now an AWS SageMaker sklearn image present, which is this. And this is what was pulled during the training. So our training is successful. Now that our model has been trained and saved in the local folder, let's go ahead and deploy it. We will use skEstimator object from the training step, since our train.py file also contains the inference code as shown here. The only difference from deploying on AWS resources is that we specify instance type as local, which tells SageMaker to deploy the model on our local machine. Let's go ahead and run the code to start the model deployment and create the real-time endpoint locally. Once the deployment is complete, as indicated by this exclamation mark here, we can verify that inference container is running locally by checking docker ps. And as you can see, there is an inference container running locally on my system, and it is up as indicated by this up sign here. So it means our inference container is operational and working. Now that our model endpoint is operational, let's test it. First, we will load our test data set. Next, we separate the actual labels from the test data. So we'll run the code. Finally, we passed the test data indicated by test_df to the predictor object that was created during deployment and compare the predictions with the actual labels. As you can see, the test data has been classified into different categories by the predictor, confirming that our deployed endpoint is working correctly. And this is the actual label, which is what we printed here. So again, this confirms that our deployed endpoint is working as expected. So with this, we come to the end of this tutorial. I hope you found this tutorial helpful. Thank you for watching, and I look forward to seeing you in the next one. Don't forget to like and subscribe to this channel for more insightful tutorials like this. Bye.